Dear students, I welcome you all for the online learning platform for the course Warehousing Automation, and this particular presentation will take us to a new unit, Unit 5, Advanced Technologies and Future Trends. So this is going to be the last unit for the course, and today this presentation will discuss about the first chapter of Unit 5, Predictive Maintenance. See, Unit 5 itself is a completely a different topic what we have discussed so far. Why I am calling different is, so this is going to be into the eyes of the future. So how this particular existing warehouse can be converted into an automated warehouse was the core discussions for the last 4 units what we had. But Unit 5 it is not going to be so. So how the automated warehouse itself will be in the near future? How can it be? What all are the different technologies might come into picture? Of course, certain technologies are not new. They are already into the picture, and still how the thing can be. So that is what the entire thing of core plot of discussion as far as Unit 5 is concerned. So within which the first topic what we are going to discuss is predictive maintenance. Okay. So there are 8 chapters are there. So the first chapter what we are going to discuss is predictive maintenance. See, predictive maintenance, in short called as PDM, okay, capital P, capital M, small d, is a warehousing automation. In warehousing automation uses IoT sensors, artificial intelligence and machine learning to monitor automated equipment like conveyors, robots, predicting potential failures before they occur. See, now first we need to understand the term maintenance. See, maintenance is an overhauling activity. See, we have got our own two-wheelers. We use the two-wheelers for commutants, local commutants. Say from our home to any grocery shop or somewhere to a market or even to working place. Likewise, we use for local commutants. See, even for a two-wheeler itself, there are some mechanisms are there as far as maintenance is concerned. The first thing is we should do certain aspects of daily maintenance, weekly maintenance, then some sort of frequency based maintenance, say once in so many kilometers or once in so much duration, we are supposed to change oil likewise. So even for a common two-wheeler application itself, we have got so many things. Think of an automated warehouse where we have got plenty of robots, conveyors, ASRS, complicated material handling systems likewise. So how the maintenance activity will be? First of all, will we be finding time for the case of maintenance? Means that itself is going to be a biggest question mark amongst or amidst the workload what we have got. So therefore, the advanced automated setup itself will have an advanced technology related to predictive maintenance. So now this particular term can be broadly classified into two aspects. The first aspect is going to be predictive and the second aspect is going to be maintenance. So predictive means before the particular maintenance activity occurs, the system should be so capable that it should predict the possible potential failure before its occurrences. Okay, before it occurs, the system should be so efficient that it is supposed to do. Now how this efficiency can be brought into picture? So the first element is we are going to use IoT based sensors. Why IoT based sensors? We don't want to have wired transmission. It's going to be wireless transmission because of the distance or because of the complexity of the nature, including safety. Safety risk assessment we have been discussing since unit 2, so that has to be considered. And second thing is the data. From the IoT sensors we get plenty of data, so we should have an AR or ML based algorithm to analyze the data, and it should come out with a consensus whether if the same scenario goes on, what will be the near future of the equipment, whether it will undergo maintenance or not. So likewise, the advanced system will be equipped with predictive maintenance to predict the potential failure before its occurrence. The next, this proactive strategy minimizes costly unplanned downtime, reduces repair costs, and extends equipment lifespan by scheduling maintenance based on actual condition rather than a fixed schedule, leading to a greater operational efficiency and reliability. Okay, so now how to understand from this particular theory part? See, usually the regular traditional maintenance activities like this, whether the equipment undergoes repair or not, one particular time, that is, it might be weekly once or maybe some duration will be fixed. There will be a scheduled activity will be there. So whether the equipment undergoes repair or not, scheduled maintenance will be going on. So there is no harm in it. It's a good practice. But the thing is, this is scheduled maintenance, so should not be at the cost of production rate. Amidst production, during production, you can't stop the entire activity and you should not engage the machine for the case of scheduled maintenance. So somewhere during leisure hour, yes, everybody is going to welcome the part, but that's going to be a tough affair when you get into a tight production. So that is not practically possible. So that's the reason why we wanted to have a predictive maintenance. If this frequency, there is a frequency being fixed, scheduled activity is going to done, that there is no doubt, but is it going to be effective, is it going to increase the efficiency, means obviously the answer is going to be no. So that is the reason we are supposed to have an advanced technology that should give us a precautionary notice before or without even carrying the scheduled maintenance. It should tell us before the actual catastrophe occurs, before the failure occurs. So that is what is predictive maintenance. Now how it works, we'll see step by step. So the first step is data collection. So IoT sensors are fixed for the vital elements of the equipments what we wanted to do. So usually the thing what we do is temperature. See, we know the temperature of the conveyor belts. So some temperature, permissible temperature is, see, upon working, right now it is in the room temperature, the work has been started. Maybe over a time, because of the load what it carries, the tension in the belt or the whatever may be the conveyor type we have got, it is going to give a temperature increment in the system. So over period of time, what happens, the temperature is going to rise. So that should be within permissible limits. If it is beyond a permissible limit, maybe it might lead to the cut off or linkage or something like that, it can happen. So temperature, vibration, see, when it is in an optimal working condition, we know what is going to be the vibration. If something is abnormal, if some sort of fuzziness into the system is there, means the vibrations will be different. And thanks to the IoT sensor, they are going to dynamically update the real-time data, and therefore we can collect the data, and from that we can draw some sort of inferences. So like cycle count likewise. So IoT sensor we use for two cases. First case is wireless, and second thing is it is going to dynamically update the real-time data. Then the second, now data has been acquired. We have got a nice system, the data has been acquired. Now what to do with the data? So that's where A and ML come into picture. So these algorithms process the large volume of sensor data to identify patterns and anomalies indicative of potential future failure. If the same scenario goes, so this sort of failure can be expected from the system. So likewise we get some sort of informations. So that's where AM algorithm plays a crucial role. Now data has been processed. Now again we should have some sort of predictive analysis mechanism. So again it is an outcome of AI. So first the data was processed by AI and ML based algorithms. Now the same algorithms are going to be employed for the case of predictive analysis. So they can identify the patterns, they can forecast the likelihood and timing of equipment failure, providing actionable insights to maintenance team. So they are going to crucially monitor the data from the sensors, and it is going to give away a warning mechanism. So proactive maintenance. Maintenance is scheduled only when necessary based on the actual condition of the equipment rather than a fixed calendar schedule. So this is what we started our discussions earlier. Now let me put a very simple example. We have got a conveyor. We know the vibrations value of the conveyor when it is working in a very prompt way. So once in 15 days, that is once in a fortnight, we have fixed, say for example, the 15th day as a maintenance day. That day equipment is spared for the case of maintenance. Now somewhere at the 10th day itself, the sensor is giving us some sort of hint. There is an abnormal sound. Usually the sound or the vibration will be, say, some 100 hertz. Now there is an abnormality in the sound. Now what is the thing we need to do? As per regular norms, if there is no IoT based sensors, we are least bothered unless and otherwise we notice the sound, we notice the anomaly in the system. So what happened is, what happens in our case is we wait for the calendar schedule, and once the calendar date, that is the 15th date come, we'll do the maintenance. But the moment when you have got an IoT based a predictive maintenance schema integrated into the machine, so it becomes easy for us. The moment anomaly is observed, immediately the equipment can be taken care of, so that costly maintenance activity can be taken care. Maybe a small bearing element or some nut or something would have been in a very minimalistic case, there would have been some problem, and immediately that can be rectified. If that is not identified, if that is not been properly pinned down, that may lead to some other thing, breakage of some shaft or something, which might be a costly affair. So thanks to the proactive maintenance concept, that is the predictive maintenance mechanism. Now there are different technologies being employed in order to do this predictive maintenance. The first thing is Internet of Things. So IoT based activity, networked sensors, especially wireless sensors. So here we can monitor the equipment condition. That is, a diagnosis becomes very easy. Artificial intelligence, so algorithms and softwares, the large volumetric data is going to be nicely analyzed, and it is going to detect the patterns and predict the failures. Machine learning, a subset of AI that enables a system to learn from data and improve their predictive accuracy over time. So AI will process the data and ML will be employed for the case of prediction. Now, what all are the key benefits? The first benefit is reduced downtime. Why? Because we are not going to adhere to the regular calendar schedule. Once there is a problem, immediately we are going for the maintenance. So therefore, unplanned activity is not going to be there. So everything is going to be properly planned activity. Lower maintenance cost, yes, avoids expensive emergency repairs and allows for maintenance to be performed at opportune times. So that's what we have been discussing. Any small element would have been it would have got damaged or broken or something like that. So immediately that can be taken care of. If not, that may lead to some costly activity. Extended equipment life. So the life as it is taken care of, so obviously it is going to work in an optimal condition, it is going to be very effective as well as efficient. So therefore the useful lifetime, economic lifetime is going to be on an increased scale. Improved productivity, so ensures a smooth, efficient and resilient supply chain by keeping automated systems running at peak performance. So always it is going to work in a very effective case. Let me put a very simple example in this regard. So now festive seasons are on the calendar, maybe within a fortnight we will be getting into it. Now the orders from a warehouse point of view, it is going to be peak. Now if the equipment undergoes maintenance, means the overall soul of automated warehouse itself is compromised. So that is not an interesting or an appreciable feature. Enhanced decision making. So since we are having data driven insights, so operators or the maintenance teams are given fed with the data, it is going to tell the equipment health and equipment performance. So it is going to ease our process of decision making. Predictive maintenance can be applied to a wide array of automated equipment, including conveyor belts. See why? Because conveyor belts are the one which often undergoes maintenance. See the belt, since it is in the tension, not 24/7, it will be in the tension, it is going to carry out the load. So the life of the belt, as it is in the tension, it is going to get teared apart very soon. Okay, not soon in the sense not within a day or so, within a restricted time. And once the belt is gone, see there might be series of activity relying upon this belt. If this belt is gone, the part from one end to the another end may not travel. So all of a sudden what happens? We need to go for some sort of major disruption. So that is not an anticipated feature. So that is where our predictive maintenance is going to help for such crucial elements. Then ASRS. So ASRS means it is going to be a complex system. We discussed a lot about this in unit 1 itself. Now one part is not working, means the entire ASRS is going to be at trauma. See, we have got tortoise shuttles which moves in 4 directions. One direction, if there is an issue, how can we use it for other 3 directions? No, obviously not. Why? Because that there is only one exit and there is only one entrance. So exit got problem means again no, whatever the part it fetches up, will not be able to take it out. So that one area where we can think of. Then robots. So analyzing the robot's operational data, especially on AMR or any robotic arm, articulated joints, yes, it is going to be an interesting affair. Then electric forklifts. So battery monitoring, battery health, guys, I am emphasizing a lot in this regard. So EVs are going to be the next crucial catalyst in automobile area. So monitoring the battery health is another interesting factor where predictive maintenance finds its wide application. Then finally, automated sortation systems. So everything comes into an area. So we wanted to employ predictive maintenance to track the performance. Why? Because everything is mixed. So that system is going to take care, that system taking care of that system itself got repair means. So the final output will not be appreciable. So that's where I emphasize the soul of automated warehouse itself is compromised here. So which is not an anticipated feature. Okay. So now we are to the end of this presentation. To summarize, so this unit 5 is going to discuss a lot about future trends in an automated warehouse, not in a traditional warehouse, in an automated warehouse. So we have got a traditional warehouse that has been automated, and now it is going to be taken for the next case where the future trends. So the first future trend is going to be the predictive maintenance. How three technologies, namely IoT based sensors, artificial intelligence and machine learning, plays a crucial role in performing the predictive maintenance we discussed, and which all are the areas where we can implement such techniques for the case of predictive maintenance we just discussed. So with this, I come to the end of the presentation. So students, please note down the doubts what you have got during our offline classes or during our online discussions. We can discuss the same. Okay. Thank you for your participation and learning. Thank you.